Lesson 3 has two parts. First part is on angles, and then we'll do construction lab number 1. And for that construction lab, you need a ruler and a compass, a mathematical compass. And those look like this. They kind of have a V shape to them, upside down V. One end is real pointed, has like a metal tip on it. The other has a pencil or a pen attached. And then you can change this angle in here, and usually there's a piece like this, a metal piece here, that you can slide that angle, make it wider, more narrow. Some of them you can even clamp them down and hold them in a specific position. So make sure you have a ruler and a compass for the construction lab. Make sure you've completed the warm-up section as well. So for studying angles, let's start out with some definitions, and that's normally what we do in geometry. We have our definitions and we may have postulates. We haven't had any theorems yet. Theorems are based on the postulates as well as the properties. We'll be getting to those soon though, but a ray, that's part of a line. That's the best way to define that. So it's like half a line, and it has an end point, and then it extends infinitely in one direction. We usually put an arrow on that other direction. Sometimes we'll have another point there, and we might label this A, this B, and we would describe that as ray AB. We would put a ray above it, not a line segment, not a line with two arrows, but just one arrow to the right, pointing to the right. Next we have an angle. That's a figure formed by two rays that have an endpoint in common. So we'd have a ray here, and here's its endpoint, and then another ray coming out from that same endpoint. That is what an angle is. And then the vertex, what we call that is this common endpoint right here. That's what we describe as the vertex. So naming angles, we can name them by their vertex, by a point on each ray and the vertex, or by a number. So for example, this angle here, we'll call it X, Y, Z, and we could call that angle Y, naming it by its vertex. We could call it angle X, Y, Z, and we could also just call it, let's say we'll call it angle number 8. That's the number we've assigned to that one. So three different ways there you may see an angle named. Well, we have two new postulates in lesson 3, and the first one is called the protractor postulate. And in your Saxon book there's a fairly involved, fairly descriptive postulate 3 there for protractor postulate, but I have a more simplified version, and it basically means the same thing. The measure of an angle is a unique positive number. So it's good to compare this with lesson 2, and we studied line segments. Remember, we talked about distance on a line segment. The distance between 2 points is the absolute value of the difference between their positions or coordinates. So we get a positive number for a result. And postulate 3 here, protractor postulate, the measure of an angle is a unique positive number. So what is a protractor? Well, it's a tool used to measure angles. That's what's in the background on this picture here. That's a protractor. Imagine you've used one before. Now degree, that's the unit of measure used for angles. So 1 degree, that's equal to about 1/360th of a circle. So half a circle, that'd be 180 degrees. 3/4 of a circle, that'd be 270 degrees. A fourth of a circle, that'd be 90 degrees. And if you think about a circle, and let's just draw two lines there, and just think about that fourth of the circle there. That would be basically a 90-degree angle. If we were to draw an angle there, or measure the angle from here down to here, that would be equal to 90 degrees. Let's draw an angle on here real quick, and we would start right there at the vertex. That's where the vertex needs to be right at that point, that hole right in the middle of the protractor, and then one of the rays needs to be lined up right there. You can see that horizontal line. You can line it up with that. So if you had an angle you needed to measure, one side would be lined up like that, and then your other one would be lined up here. And then we would measure, we would go in this direction, we'd say that's 0, and then go up to here and see what the angle is. And you can see here you have 170, 160, 150 like that. We don't want to go that direction. We want to go in an increasing number. So we'd go 10, 20, 30, 40, 50, and then let's go up here because we have increments of 1 degree. So instead of saying 130, we'd say 50, 51, 52, 53, 54, 55, 56. So we'd say that that angle there is 56 degrees. Now, just something to keep in mind as you're doing your lesson, sometimes they're going to ask you to measure an angle, and if you have to use a protractor to do that, it may be fairly difficult for you to get the same answer that they have in the book. So just be aware of that. If you're within a few degrees of their number, 2 to 3 degrees, then that's fine. If you're 10 degrees off, then you should count your answer as incorrect. But sometimes it is difficult to get an accurate answer with a protractor. So you need to be within 2 to 3 degrees of the book's answer. You don't have to have the exact answer that the book has. Now that you understand what degree is, we can talk about some different types of angles. An acute angle, their measure is between 0 and 90 degrees. Greater than 0 degrees, less than 90 degrees. Then you have an obtuse angle that measures greater than 90 but less than 180. A right angle, that's exactly 90 degrees. That's why an acute angle doesn't equal 90. It's less than 90, greater than 0. A right angle measures exactly 90 degrees, and on a right angle you might see that described with a little box on the corner right there. And when you see that type of angle, then you know that's a right angle when you see that little box on the corner. And then last, there, straight angles. Those measure exactly 180 degrees. Straight angles would just be common endpoint there, a ray going in this direction, a ray going in the exact opposite direction. So this measure right there would be 180 degrees. So for now, no matter what kind of angle it is, the measure of it, if you measure it, it is a unique positive number. Well, let's go on to postulate 4. Postulate 4 is the angle addition postulate. And it says if point D is in the interior of angle ABC, then the measure of angle ABD plus the measure of angle DBC equals the measure of angle ABC. Now look at the comparison here between that and postulate 2 we just did in lesson 2. Postulate 2 is the segment addition postulate, and it's very similar. There's an analogy or a comparison between the two. Now it says if B is between A and C, then AB plus BC equals AC. So they're talking about distances there. In postulate 4 we're talking about angles, adding angles up. So just to think about this a little bit, if we have an angle here and we'll call it angle A, B, C, and point D is in the interior. So here's the interior in between the two rays. The exterior would be outside the two rays. So let's put another ray right there, and we'll call this point D. The measure of angle ABD, which would be this right here, and sometimes you'll see that curved mark representing a particular angle, plus the measure of angle DBC, the sum of those two is equal to ABC. And that seems pretty obvious. Remember, postulates are things we assume to be true without proof, so a lot of times they're fairly obvious, fairly easy to understand. Sometimes postulates are a little less obvious than this, but the interesting thing about them is that they are true. They've been true for thousands of years. They are going to be true thousands of years from now. Things that are true don't change over time. And a definition based on postulate 4 is angle bisector. That's a ray that divides an angle into two congruent angles. So if you had an angle, a bisector would split it right down the middle, and you'd end up with this angle being congruent to that angle. And sometimes those are represented with tick marks. If they both had one tick mark, that would represent that they are the same angle. They're congruent. Let's go ahead and do some practice problems now. And look at problem A here. Name 3 rays and 3 angles in the diagram. Now remember, you are supposed to be taking notes on this. You don't have to draw this diagram, but you do need to answer these questions on your paper, and hopefully you've been taking notes on the lecture as well. So there's more than 3 rays in this diagram, but let's just name a couple of them. We could do B, A, and we put the arrow on one side there on the top. Usually we put the endpoint first, and then we could have B, J. So again, put that arrow up there, and we need to name 3 of them. So just another one, it doesn't matter which one, I'll say B, C. And then 3 angles in that diagram. So we put the angle symbol, and then we can say A, B, C. That's one angle there. and the vertex is always the middle letter there, and then we could say angle A, B, J. Again, there's more than 3 angles, like there were more than 3 rays too, and I'll just pick 3 here. Angle D, B, K is a third angle there. Next, in B, we want to classify angle DBC and use a protractor to find its measure. So classifying it means, is it an acute angle, is it obtuse, is it a right angle? And here we can see it right here, DBC, and it's pretty obvious that's an acute angle, and of course you could measure it with your protractor to confirm that, but hopefully you're familiar enough with angles just to be able to look at that one and tell that it is an acute angle. And hopefully you have a protractor so you can line it up right there, that hole in the middle of your protractor, line it right up on the vertex there, and then the ray BC, line that up along the bottom, and then you can actually put your protractor on the computer screen to do this. So go ahead and do that and see if you can figure out what the angle is. Well, the actual angle here is about 34.7 degrees. Now remember, you need to be within a few degrees of that. So between 31 and 37, 38 or so. It will be difficult, especially on some of the problems in the textbook where they give you a really small angle and your protractor doesn't fit. If they give you a real small angle like this and your protractor just doesn't seem like it's going to fit, then just try to extend the lines. Use your ruler and extend the lines on out on your textbook. Just write onto your textbook with a pencil. Do it lightly so you can erase it over, but extend them out so that you can get a better idea using your protractor what that angle measure is. In problem C, let's figure out the measure of angle ABJ. And we've been given some other angle measures there, so probably what we need to do is do a subtraction here. And so we see measure angle ABC is 133.3 degrees. So we know that angle right there. Then the measure of angle DBC, that's 34.767. We know that right there. And we know what the measure of angle JBD is, this angle right here. We know that one. So think about your angle addition postulate here. We could say 52.7 plus 34.67 plus the measure of angle ABJ. The sum of those three is equal to ABC, 133.3. And so if we do the math on that, we just take these two, you can add them together, then subtract that amount from both sides, moving that over to the right hand side there, and you get measure angle ABJ is equal to 45.93 degrees. So that should be what you obtained for the answer there. Let's do another problem here. It says the measure of angle DBK equals 17.34 degrees, and then the measure of angle JBD equals 52.7. Find the measure of angle JBC. So we know this right here, DBK is 17.34. Now those marks there, those curve marks, those are telling us that those two angles are congruent. So BK must be an angle bisector. We can assume that's what those tick marks are telling us, is that those two angles are congruent. And so we would say 17.34 as well right there. Then angle JBD, it's a different angle, so we could put a mark there in the middle to distinguish it from the other two. We could say that's 52.7 degrees. So now we have 52.7, and we'll just put a 0 on there for that decimal place, and then 17.34 times 2, that would be 34.68. So we end up with angle JBC 87.38 degrees, and so we could say measure angle JBC equals 87.38 degrees. And it's important to put that degree symbol on there. That's the unit for angle measure. So just like it's important other times when you're measuring things to have the units shown, if they're given, then that's important. So here we know that we're dealing with degrees, so we need to write that degree symbol. Let's do one more problem, practice problem E. It says a survey shows that 30% of students prefer steak. What would be the degree measure of an angle indicating these students on a circle graph? Well, hopefully you've seen a circle graph before, and it's called a pie chart also. And so let's just draw a circle on here, and let's think about what 30% of that would look like. Well, just estimate for right now. 30%, that's almost a third of the circle. So we know that if, let's just draw a line right there, it would be more than a quarter, so maybe something like that is what it would look like, something greater than 90 degrees. And we learned earlier that the definition for 1 degree is 1/360th of a circle. So 30%, we need 30% of 360 degrees. So we would just do 0.3 times 360, and that would equal 108 degrees. So that would be the degree measure for an angle indicating the number of students who preferred steak. And so you can just imagine if this was some kind of survey and it had other parts to it too that filled up the entire circle graph. So a percentage that preferred chicken, a percentage that preferred pizza, fish, and so on. But 30% of 360, that would be 108 degrees. That's how much would be shaded in to represent students who preferred steak. Let's go on to the construction lab now, and in this lab you're going to make geometric shapes. You're going to use the same tools that Euclid and other students who studied geometry over 2,000 years ago, they used the same tools to study geometry, and they didn't do any measurements. They didn't use the units on the ruler like centimeters and inches and things like that. They just showed that they could make congruent things. They could prove theorems just with a ruler and a compass. So first let's make some congruent segments. And so to make a line segment, we know we need at least 2 points. So you need to put a dot and then another dot, and then use your ruler or straight edge. And the reason they call it a straight edge is because it doesn't have to have ruler marks on it. It doesn't have to have inches and centimeters because you're not measuring anything. You just want to make a straight line segment. Now, how are you going to make segments, line segments, that are congruent to this one? Well, the first thing you need to do is take the compass and put the point of the compass right there where I just made that dot. Put the pencil at the other end, down there at the other end point. And all you're going to do, line those up, and then you're just going to make an arc like that. And then what you do is you can just put some dots on there. I'll put one here, and one there. You can do more, you can do less than that, it doesn't matter. But a circle is basically what you just drew. You drew part of a circle, and a circle has the same radius everywhere. It has the same distance from its circumference, from its outside edge to the center. And so if we take our straight edge and put it on one dot and then draw a line segment down, we've drawn a congruent segment to the original one. And then we can do that again here. There's another one, and it's kind of like spokes on a wheel that we're drawing here. So we have 3 congruent segments, congruent to the original segment. Now, of course, they're not perfect. They're not exactly congruent, but we'll always have some human error involved with this. And we'll define circles in another lesson, but for now, just know that a circle, because the distance from that outside edge of the circle to the center is always the same, you can draw congruent segments. Well, now let's go on to congruent angles. And to make an angle, we know we need at least 3 points. So let's put 1, 2, 3 points. And then let's use our straight edge to connect those endpoints together. And we just go ahead and do that. And there we have an angle. Now, how would we make an angle that's congruent to that one? Well, we just need to make one of the rays. So let's just put a couple of dots over here, and we'll draw a line in between those, a line segment using our straight edge. So now we have our base ray. Next, go over to the original angle and put the point of the compass right there at the vertex of it, and then put the pencil out here towards the end of that ray that you have drawn there. It doesn't have to, don't make it too close to the vertex, but make it pretty far out, and then you'll line up and you'll go ahead and make an arc right through there. Then you'll transfer that arc over. You'll put your point of the compass there on the left side of that line segment that you have drawn, and then you'll draw another arc, make it nice and big, as big as the other one is. Now what we need to do is find this intersection point. If we can find that point, then we'll have that point and the vertex point, and we'll be able to draw the other ray. So what you do is you take the point of your compass, put it down here at the bottom of that original arc you drew, and then line up with that intersection there, make an arc, transfer that arc over to the other angle that you're constructing, and now you're ready to go ahead and take your straight edge, line it up with that intersection there, and line it up with the end point on the left, and there you have your angle, your congruent angle. And then you can take an eraser and erase those parts that you don't need in the construction, kind of like your scaffolding is what that is. Just like if you were building a building, you'll have some structures that you don't need anymore, and you remove those when you're finished with your construction project. Now, how do we know that those are congruent? Well, one thing you could do is check your work. You could take a protractor and put them on the two angles that you made and compare them, see if they're within a few degrees of each other. And using a protractor to measure those two, you can see that mine are off by about 2 degrees, so that's not bad. See if you can do yours a little more accurately. Okay, well that's all for Lesson 3.